So we'd like to invite our guest speaker today, Professor Dr. Christina von Haren. She's been with us since yesterday, and I think we have overstretched her time and trying to make best possible use of her expertise in meeting and connecting and networking with people at the AUB. If I give something about her background, she has been a full-time professor for landscape planning and nature conservation at the Institute of Environmental Planning, Leibniz University, Hanover, Germany. Since 1998, she has worked on projects about supporting planning using IT and on ways how to model biodiversity on agricultural land in order to engage land users in environmentally sound practices. Her work also focuses, since more than a decade, on renewable energies, in particular their spatial allocation. Dr. Christina von Haren was member and vice chair of the German Advisory Council on the environment from 2000 to 2008. She has been dean of the faculty from 2010 to 2013, and at present she's working on research projects about nature-compatible renewable energy supply for Germany in 2050, uncertainty in planning, and ecosystem services and decision processes. We are really curious to listen to you today on this topic. Please.
Thank you very much, Nasreen, for this very kind introduction. And also, I was very thrilled to hear the talk of Dr. Mortar, because I think there's a lot which the two countries have in common, and also there's still quite a way to go, and maybe also to go in parts together. And I would like to, first of all, I would like to point out that what I present today is the work of a team, and it's a mixed team of environmental planners and technical engineers, especially electrical engineers from the University of Hanover, but also from extra university institutions who worked on the results. And I also would like to point out that this working together with the the grid people, the storage people, that was very, very productive for us, and I think also for the other side, because we understood much better the connections between the spatial perspective and the technological advancement and development. And I hope I can illustrate that a little bit in my talk. Now, Germany in the world is usually looked upon as a front runner in renewable energies. And I would like to start my talk in kind of throwing some figures on you, which show that what we do in Germany looks quite nice, but we still have a long ways to go. And maybe we can go part of this way together. So when you hear figures from Germany, you hear, for instance, 30% of renewable power already now, and that sounds very nice. But when you look a little bit closer, you see that this little word, power, is very important, because that is not the gross, the final energy consumption, but it's only the electricity consumption, which is covered at 30%. If you look at the complete energy consumption, including all the burning processes, you see here that this is the electricity, and this is the share of the total energy consumption, which is now covered by renewable energies, and it's much less. It's only about 15%, so only half of what the German government likes to put forward in international talks. Also, a lot of this, what we provide by renewables nowadays, is covered with bioenergy. And bioenergy, as we will also see later, is not a very efficient source of energy generation, especially in terms of the space, the spatial factor. And Dr. Motar pointed out that the space is also a very important minimum factor here in Lebanon. And the same is true, so we have something in common in Germany. Space is the most expensive and most competed resource in Germany, because building, agriculture, recreation, all kinds of uses compete about space, and of course renewable energies. And my last kind of introductory figure is about how much is invested in renewable energies at present in the world. And you can see that China has become the biggest investor in this field, and also because the Chinese government is heavily investing, while, for instance, a big share of Europe is in Germany, while the German government has cut back investments in, or you could call it subsidizing of renewable energy. The subsidies is not so much, but for instance, the solar energy has become now quite cheap in meantime, also because it's produced in China. And so it has become just a thing which people put on their roof, and it pays for itself. We have to work on the time to pay back the money, the invested money, but nevertheless. But we have to realize that China is really very strongly promoting this now. Now, we have our sustainability goals, and a lot of you might know this picture. And when we talk about renewable energy, of course, that is one of the very important sustainability goals, to produce clean and affordable energy. And in Germany, we have adopted this this SDG, the sustainability goal. But at the same time, this goal is competing with other goals, such as the biodiversity goal of the Convention of Biodiversity, water, soil, and so on. And it's a little bit cute maybe, but in my own house, this kind of struggle between the competing sustainable development goals is taking place. We have already solar thermal on our roof, but my housemates, they want to put also PV, photovoltaic on the roof, but there is a birch tree, a beautiful large birch tree, which is shading the roof. And so we are kind of discussing what can we do. Of course, I want to protect the tree because I'm also a nature conservationist, and they want to cut it down. So I felt very bad about this because I was feeling like hindering the German energy transition in my individual behavior. So I was, and I was not alone, because this struggle takes place in the whole German society. We have a lot of protests by now against, especially against wind turbines. And what you see here is a banner, one of many banners which you can find in the country, and it says, "For nature and quality of life, against greed for profit." Because now people putting up big investments in wind turbines, they are thought to make profit, and the local community will have the cost in terms of deterioration of the landscapes, nature conservation. People will be affected by noise from the rotor blades, and again, the area is the scarce and limiting factor here. And also, this protest is instrumentalized now by political groups. And I put here a citation of the energy, or the climate protection agency of Hanover. They said, Hanover region, we are out at our wits' ends in regional planning as to allocating wind turbines. So we thought we need to do some research on this. What can be done? And first of all, I was very relieved when I saw this picture of the Sustainable Development Goals, which gave me some orientation and took a little bit of the load from my shoulders. And the Stockholm Resilience Center designed that. And they put a hierarchy into these SDGs and said, okay, people, if you don't protect your life on land, life in water, if you don't protect your climate, then all these other objectives will not be reached. So please make sure that this is sound and then develop the other goals. So that's what we wanted to do too for Germany, and we were very lucky that the German Ministry of Environment financed our research. And our basic approach was that we wanted to be very ambitious and explore the feasibility of a 100% renewable energy target, which at the same time respected human and nature conservation demands. And we wanted to put these demands, human and nature conservation, first, and then look how much energy can be generated. We also used extreme assumptions in our, we were producing and modeling scenarios for clarifying, for showing the politicians in which direction to walk. Using extreme assumptions is important because politicians will always deviate from what you propose as from a scientific point of view, but to make clear what would be the really good path to go, and then you still may deviate, but make clear what should be the right direction. And as we know, everybody is deviating usually, so we said we also need reserves, kind of savings, and with our extreme assumptions, we said we will have enough room for deviations from the path and also have room for local participation or local discretion. Also we wanted, because that's something which is in Germany not very well done usually, we wanted to define the local or maybe regional responsibility and share in reaching the goal of the energy transition. Usually you have nice goals on the national level, and then on the local levels everybody says, not in my backyard, let the other municipalities do it, or other regions. So we wanted to make clear what is the individual share of each municipality and each region. And finally, we wanted to define the uncertainties of our very broad-scale calculations and prepare a participative approach. So you see, this is quite complex, and it also mirrors a little bit what Dr. Martin said before. You need the institutions, and you need the three I's. What was the first? The infrastructure, the institutions, and the individuals. So also the individuals have to be taken care of. There's a lot of parallels there, I think. So we designed extreme scenarios optimized for nature conservation and noise protection and aesthetical protection for people. And our objectives, which we put in our models, was we want 100% renewables for the total energy consumption in Germany in 2050. That is now what people have figured we need in Germany if we want to meet the Paris goals, which Lebanon signed and Germany too. And 80%, that's the old German goal, will not be enough to be under 2 degrees Celsius temperature rise. The next was that we wanted to protect species and habitats. Not only, I'll come to that later, protection of beautiful landscapes, protection of people from noise and visual disturbances, and we did not want to use area for agricultural production, which is in use for food production right now. As I said, we have more than 2 million hectares for renewable or for energy crops right now. So we took that area into account. Okay, so we put into our model all existing protected areas, but also additional areas with sensitive protected bird and bat species. We modeled kind of the target areas of the German biodiversity strategy, which are not published in any kind, but there are some principles which we made concrete for the areas. We have another model about the landscape amenities in Germany, and we took the best third of the most beautiful third share of landscapes, and we calculated safety distances to settlements and infrastructure as to noise. Also, and that we didn't, another group made a projection about the electricity demand in 2050. You can ask me later what they took into account. And they figured that we will need in an ambitious scenario, so good technique, people will comply and so on, about 820 terawatt hours per year for Germany, and plus 315 terawatt hours for fuel, plus the storage loss. When the technical details we can discuss later, but we took another 50% of this sum, added it up for storage, which is not the electricity you use, but you use for transformation processes in storage. And we presumed that storage and power supplies will be enlarged in 2015 and 50, and that we will have photovoltaic on all suitable roofs in settlement areas, as well as proportionally on facades, so walls of buildings, and on traffic areas or over traffic areas, like photovoltaic over parking lots and things like that. And in these first scenarios, we restricted, or we said we will only put wind power in rural areas and not yet photovoltaic. But photovoltaic is completely suitable also for agricultural areas. We did not consider biomass, because biomass is horribly inefficient as to its spatial output of energy. And you can see here in Central Europe, we might produce about 1,000 kilowatt hours per square meter and year. And you have a much nicer situation here, because in southern latitude you can produce more than double. Nevertheless, solar plays a very important role in Germany too, not only in the energy mix, but also because it's an effective energy source there. And don't look at the wind here. This is calculated for wind farms, so the area, which you could also have crops under the wind, under the turbines, but they calculated here for the whole wind farm, and there they have to keep safety distances between the devices and so on. But I would like to point out the big difference between biomass and solar is a very powerful energy source. The scenarios calculated with different technical devices in the area. We kind of planted in our model different wind turbines so for instance, this is a turbine which is state of the art in Germany right now, and we figured how big is the distance to settlements if we would use it on all areas which are suitable in terms of protecting nature and humans. And you find it's about in a very kind of extreme calculation, you need 2 kilometers distance between the settlement and the power plants. And if you take a 2050 plant, which probably has even more than 200 meters hub height, the noise will be much stronger, so you need more distance between settlement and the wind power plants. And in a third scenario, we just put smaller plants in the area between the settlements and the plants. So that was an extreme scenario, and we calculated also another one with less big distances. This is according to the German standards from the emission law, noise emission law, which we have, and you can see here the distances are less than half what we took into account in our first round. These are all the standards which we have to comply with anyway. And then it was very interesting to see which area we could use for the plants, for the turbines. And when we put everything together, all the excluded areas, nature conservation, recreation, settlements, and so on, what was left was only 0.5% of the country where we can put plants. And the Ministry of Environment was very frightened when we came up with this figure. But we said, we have been extreme, and we have still quite a lot of area left where you can put plants, but you have to comply with more restrictions there. And we call this the spatial resistance of the countryside. So this is kind of our decision space. This is the area where we can put the plants. And then we calculated the energy which can be produced there. And we had a model we had data about the roofs, or not the roofs, the buildings, and calculated the suitable area for photovoltaic on roofs in Germany. And it turned out that is a very big chance to produce energy. We have in this is scenario 2. So the middle scenario, you have 65% solar energy from rooftops, and this is the existing and the new wind power, which we will need, or which we will have to satisfy the rest of the demand. And when we calculated what came out of all of this, we found that we can produce quite a lot of energy with this energy mix, and that it will be enough to satisfy the demand, at least of electricity. But we still have the rest of the demand, which cannot be met by electricity. You need fuel. Those are some industrial processes which need fuel, but also aeroplanes, ships, and so on. They are not so easy to electrify. That's at least what the technical engineering people told us. So we had to look for how can we satisfy that demand, and also have something in reserve. And then we calculated our energy scenarios, and we found, okay, we have quite a lot of surplus energy which can be produced on this very, very limited spatial resource. I really want to point that out. That was very, very extreme. And we calculated for the non-electric demand and found, okay, we will need about this, in the different scenarios, we will need, or we will be able to produce non-electrical energy on the rest of the area. And we came out quite nicely, as you can see. So the important message to politics was that the demand in 2050 can be met without impairing nature, recreation, without impairing people by noise, and so on and so on. But the important precondition for this was that you kind of plan everything. And we are old enough to know that is very hard to achieve. Even in Germany, and in Eastern Germany, the planning economy didn't work very well. So even in Eastern Germany, that will be hard to achieve. This is just to show you what we are starting now, or what we have started now. Now we have a kind of, or we can calculate different scenarios, and we know where the turbines will be situated, and also where the solar energy will be produced. And this is now taken as an input data by the grid people, who calculate what is the consequences for the grid. In different scenarios, we can vary everything, and they found that when you have so many small producers, they found in this example that you had to increase the network stations by about 75%, and you need a lot of a medium and low voltage grid that would increase by about 1/4. So this model coupling is now generating new knowledge about the dimension which such a sustainable development of the energy transition will have. And also in the next step we will calculate the storage devices by this allocation. So now, because we don't want this, or we are not so positive about this completely planned transition, we said, we had these reserves because we had our extreme assumptions, and the reserves, they consist of more offshore energy. We didn't calculate the full potential of the offshore energy. It consists also of open space solar farms. We start now just a smaller project about agro-photovoltaic, for instance, putting photovoltaic over the farmed area at a height of 4 meters and things like that, and then you can grow special crops under that. We need a little bit of shade, especially interesting here maybe. Wind energy also in areas of medium sensitivity. More geothermal, also there the full potential we didn't take into account. We also thought of change of lifestyle, which we didn't account for yet. And import of energy, why not? Trump is saying Germany is exporting too much. Maybe we can do a little bit about our import-export balance, or accounting by importing energy. But the precondition would be that the energy would be produced in the same sustainable way as we would try to do it in Germany. And then finally, and that is also maybe interesting for cooperation here, technical innovation. We took some technical innovations into account, but there is a lot of leeway, I think, for innovations which try to avoid the environmental impacts from the beginning. So noise-reduced wind turbines, or different things you can think of. And we have already some small examples. This is an example from Germany. I think Siemens is included. This is an example from Iceland, very aesthetic. This wouldn't disturb a landscape very much if you had a turbine like that. Tidal power. Then the French government wants to implement 1,000 kilometers of solar roads during the next decade or years, I don't know. The Dutch are very inventive. Again, they are always bold in doing things like that. This is also a wind turbine thing, but it includes hotels, shops, residential places, all kinds of things. And finally, this is DT Bird. It's just emerging, and I don't know how it will perform, but it makes the wind power plant or the wind turbine turn away if a bird is arriving. So, and at our institute, my colleague Michael Reich, he has developed a device for bats. It's an intelligent bat, the mammals who fly. They have a very a behavior which you can calculate very well. They fly at certain times, temperatures, and so on. And DT Bird is going a little bit in the same direction. Now, the last step, of course, was now to address the institutions and the individuals. And we made some recommendations, especially about quantitative targets, which you can scale down now from the national level. You can say, okay, municipality X or region X, you have a potential for producing human and nature-friendly energy of whatever, and please now try to live up to the expectation, and also include your citizens in a participative process, because there is leeway for participation. You can allocate your plants in areas which are not so sensitive and choose the type of plants, whether solar or wind. So there's a lot of things local communities can still decide on, but it is very important in order to meet the Paris goals that you have a kind of monitoring process which is upscaling the local results or the local achievements, the performance of the different communities up, municipalities or regions, up to the national level again. And also now we are just checking uncertainties. I will go through that very fast because it's just an illustration that we have now when we go down to the regional level. This is data on national level about the buildings. This we have on regional level, and we can calculate how good is our national, how good are they, the national data, which we downscale now. Or here we have much more information about the buildings now on the regional level. And we are not so bad when we compare, for instance, for the region of Hanover, all these green points where areas where the region of Hanover wanted to allocate wind power plants, and which were in line with the areas we had calculated from the national level. Also, you can start optimizing and giving decision support to the regional authorities what they want. When you have a trade-off between the environmental sensitivities and values and the energy production, which is shown here. In the region of Hanover, I'm afraid we have 0 area which meets both demands, but you can bring that together. And for instance, this area, you have quite a big energy yield per hectare, and it's only medium sensitive. So yeah, the decision makers can somehow put together what their preferences are and calculate what they can achieve by that. Also, we start now to develop a user interface for the participation process, and we would like to end up with something like that, where you can change your or the municipal or local energy design, energy mix, energy design, put it on the map, and the software should calculate your energy yield, but also the trade-offs in terms of environment. So that's where we're heading, and we would like to have partners in this endeavor. And yeah, that's it. Here we are trying analog still with some farmers' wives, our concept, basic concept, and it went out very well. And I'm at the end of my talk, and thank you very, very much for